Let us discuss the equivalence relation. Important concept in class 12th. Okay, relation we are already aware with, and we know that this is the symbol for the relation. Okay, now equivalence relation is that type of relation which satisfies the three properties of reflexive, symmetric, and transitive. We will discuss one by one. So a relation R defined on a set A is called equivalence relation if R satisfies the following properties. Okay, number one is reflexive, two is symmetric, and third is transitive. Reflexive property says that every member will be in relation with itself. Means A belongs to the relation. That is, A is in relation with A. For all A belongs to the set A. Symmetric property, A is in relation with B is in relation with A. Means if A is in relation with B, then B will also be in relation with A, and for all AB which belongs to the set A. This is the symmetric property. Transitive property means AB belongs to R and BC belongs to R will imply AC belongs to R, means it is like this: A and this C, transitive, will belong to R. Means if A is in relation with B, B is in relation with C, then A will also be with relation with C. For all ABC belongs to A. This whole concept will be much clearer with the following examples in the next slide. Let us see. Relation of parallel lines is an equivalence relation, but relation of perpendicular lines not an equivalence relation. Why? Let us discuss. In case of parallel lines, any line L is parallel to itself. Okay, so L is parallel to a reflexive property. When one line is parallel to the other line, then other line will also be parallel to the first line. That is, if L is parallel to M, then M will also be parallel to L. This is symmetric property. When line L is parallel to M and M is parallel to N, then L will be parallel to N. So transitive means L is parallel to this N. So parallel line concept is equivalence relation. Now in case of perpendicular lines, what happens? See, any line L is perpendicular to itself, no problem. So reflexive it is. When L is perpendicular to M, then M will also be perpendicular to L. Symmetric property also, no problem. But when L is perpendicular to M and M is perpendicular to N, then L is not perpendicular to N, means L is not perpendicular to this N. Rather than L will be parallel to N. So it is not transitive relation. For that reason, because it is not satisfying the three parts, all the three parts, so perpendicular line concept is not an equivalence relation. One more example we'll discuss in the next slide. See, on the set R, let x is in relation with y if and only if x is less than y. For any x, y belongs to R, set of real numbers. Now see reflexive. For any real number x, x is less than x is false statement because 2 is less than 2. Not true, so reflexive, not satisfying. Symmetric. For any real number x, y, if x is less than y, then y is less than x is false because, see, 2 is less than 3, but 3 is less than 2. Not true. So symmetric also not satisfying. Cancelled. Transitive. For any real number x, y, z, if x is less than y and y is less than z, then x is less than z. So it is transitive. So it is, suppose example, 2 is less than 3, 3 is less than 4, so 2 is less than 4. So this property is true, but it is not satisfying the three properties. Only one last property is being satisfied, that is transitive. So it is not an equivalence relation. Therefore, this relation is not an equivalent relation. Thank you.